Maybe you'd have to be a workspace admin or owner to do that.
Maybe. Yeah, maybe that's why. All right, let's start with.
Yeah,
Yep.
I'm just sharing my screen. Let me know once you can see.
You can see it.
Okay. Okay, so let's get started. So in the first lecture, Jeremy showed us how to train some models using some data sets. So one of them was to predict whether it's a cat or a dog. So I'm gonna take that example and show you how the code is exactly working. So in the second lecture, Jeremy mainly talks about how the code is working and how you train a model in a more of a theoretical way, because he doesn't want you to go into the deep into the maths yet. So let's get straight into the code and see what is exactly happening. So this is the code that I have taken from the notebook. So this is basically predicting whether it is a cat or a dog. And so the first line of code is basically to take the data set and untar it and keep it in this path. Okay,
Right.
so yeah, so yeah, so the next thing is this function, which is basically a label function to assign a label to each image in our data set. So in this particular data set, you can tell whether it is a dog or a cat by seeing the whether the first position of the file name is uppercase or a lowercase. So if it is an uppercase, then it's basically saying it is a cat, so it will return true. And if it's a lowercase, then it's a dog. So that's how this data set is designed to be. So that's why we are using this kind of a label function here. Okay, so before going further, I would like to discuss one important jargon that we need to understand here. So if you look at the labeling function, it is returning whether it's true or false. And in this case, we are trying to predict whether it is a dog or a cat, right? So when you're trying to predict a category, so when your label is a category, it is basically a classification problem. So on the other hand, if you are trying to predict how tall the animal in this image is, or what is the age of this animal, so, and if you're trying to predict a numerical value, basically a continuous variable like height, weight, then it's going to be a regression problem. So in this example, this is a classification problem. So going back to the code, we have looked at another important thing, which is
In this case, I think it's a Boolean, right? So label function, it's a true or false. It's a Boolean.
yeah,
It's not either. So it's categorizing into, at the end of the day, it's numeric, right? If it's 0, it's like false. If it is 0, then it's a dog. And then if it's 1 true, it's a,
yeah,
yeah.
but it's not a continuous, right? It's a discrete value.
Right, right. It's a,
Yeah, if it's a discrete, and in this case, this is a binary classification. So you are trying to predict whether this is a 0 or a 1, right?
and I have seen it used, like not here, but like in a number of stuff that
Mhm.
I have gone through, that classifying into numerics, even if it's discrete, like if you have 10 categories, classifying into a category helps a lot more with the speed of the execution rather than having a string.
Mhm. Okay. And here, if you are trying to predict the probability, then it's going to be a regression problem.
Mm, Not sure about that.
I think even the here what it does is basically probability, right?
Yeah,
So
even
I
here
think
it's
all
Yeah.
machine learning algorithms use a probability, like how sure I am that this is an image of what you want me to do. And even here
Mm-hmm.
it is a probability, like the machine says that 99% I'm sure this is a cat, or 88% that this is a dog. This
Yeah,
is not
yeah,
a cat.
yeah,
right.
yeah, yeah, right. Hmm. Okay.
So if it were not like um, two categories, if we had like three or four categories, could we provide a function that labels them as cat, dog, elephant, duck, or something, or
Hmm.
would we have to provide numbers? So I haven't tried it. I probably should have tried it before asking this question, just in case you know.
I think, yeah, I think I have tried a few. Like it's better if it's numeric. I
Okay,
mean, maybe the deep learning algorithms and GPUs won't care that much. Maybe these algorithms that they have here will automatically convert it into numerics. Maybe,
yeah, yeah,
Mm,
but like I have used a couple of scikit libraries, which is a Python-based machine learning library,
right,
and
yeah,
they generally couple of things that they do is one is normalize, and second thing is if you have to define it to categories, do it in numerics. That's the like two basic things after cleaning data.
okay.
mm-hmm. Yeah, yeah, yeah. You
In case of
would
scikit,
have,
yeah, go ahead. Sorry.
yeah, you would have to convert your labels into numeric. So basically, it's a kind of encoding that you do when you are uh, passing the labels to the model. You will basically pass those numeric values only, not these true or false
Okay. Yeah.
or
In
the
case of
categories. So
scikit
yeah,
learning,
go ahead.
thing is when you define a classifier or a model, you basically tell it that it's a classifier or a regression model
Yeah.
at this
Mm-hmm.
when you're
Yeah.
defining the class itself. So the model knows whether it's regressing or classifying. But in
Mm-hmm.
Right.
here, you're not specifically saying that, right? So just have label. Probably when you say label, it's classification, and when you have a y value or something, it's regression or something.
Yeah. Exactly.
Yeah, that's a good observation. Couple of next ones we have
Hmm.
numeric.
Right. Okay.
Okay. So going back to the code, we are looking at this valid percent is equal to 0.2. So this is nothing but a validation data set of 20% of the overall data that you have. So this tells Fast AI to hold out 20% of the data and not to use it for training at all. So this validation data set is basically used to measure the performance of your model. So if you see here, you're trying to print out error rate, right? So this is basically calculated on the validation data set and not the training data set. And we will see why that is. Uh, so by default, even if you do not uh, give this parameter, the valid percentage, by default, Fast AI keeps aside 20% of your data. So even if you forget to do that, Fast AI does it for you so that uh, so that it may not lead to an important jargon which is overfitting. So what is overfitting? So overfitting is overfitting basically occurs when you try to train a model for too long, and or if you have not enough data. That means you have less data, like only like 50 rows or something, or with a model with too many parameters. So when so your accuracy gets to tends to get worse after a while. So we use a validation data set so that it does not happen. So basically we are using validation data set, so we are not going to have a problem with overfitting the model. So overfitting is like overfitting occurs when your model is performing very well on the training data set, so, because it has already seen all all examples that are in the training data set, right? So it may try to remember those training data sets and try to remember that this picture is a cat. So it will not basically trying to learn what are all the features. So to avoid that problem, we are taking validation data set here.
I have a couple of
Hmm.
not related to this, but the validation data set that
Sure,
we have.
sure.
So in the later examples, right? The slides all mention about validation being a 20%, being on a future one, like a time series, right? You have the
Mm-hmm.
past data series, but the latest data series, that is what you should have the validation set. Should not pick randomly from the validation data set, right?
Yeah,
Right.
yeah, yes.
So, what do you guys think about that? Like, is it always the case? I mean, most likely, like everything is at the end of the time series. Like you can anything you can point out real estate prices, or maybe tumor sizes. Everything could be labeled as time series, right? Everything like tumor sizes grows from small to over a period of time. So, but I would like to know, like, have you thought about any cases where it would be better fit if random? It would be random rather than a time series, like the last part. Have you
Um,
guys thought
so
about it?
you yourself mentioned like tumor sizes. So let's say you have a set of images, and then you have to classify the images which have a tumor in them. All right. So this is not particularly a time dependent data set. I mean, you couldn't have images from maybe 10 years back and some images that are like more recent. So in this case, I think even if you do a random sampling instead of picking up, the most recent images of the tumors would still work. I would rather say that you should pick random sample instead of picking the more recent images, because the recent images are more better quality images compared to the previous ones, maybe, which were not so high quality since they were not such good cameras. But
So then it's data dependent, what kind of
yeah,
data we have,
it's
right?
data
Like
dependent,
if it's
and
time series.
Hmm.
it's time dependent. Yes, then you would want a recent validation set. But if it's something that's you know uh, indifferent to time, then you would probably use a random sample.
So one second. So if you see here, this graph is basically for the sales, right? So sales are like basically having a seasonality in them, right? So for each season, the sales may be different. So this is a kind of a time series. But what Ocean was saying was does not have a seasonality in it, right? So when your data has a seasonality in them, so by randomly picking them, so if you randomly pick some numbers, right? So if you pick pick this for your training data set, so it will know because this is your training data set, and here some number is here some point you have set aside to validation data set. So from the previous points, the model will know that if uh, if it's occurring in some date, suppose take this as a date, we'll know that because with respect to these points, this is decreasing. So it will basically try remember that if it's something like this, then it may be a decreasing value. So it will try to predict that. So there should not be any seasonality in the data set.
Right.
Yeah,
Yeah.
that's what time series is. Time series data basically has a seasonality in them. So picking random points from them is not a good idea. So you will try to set aside the last month sales available data, and then you try to predict for those last month sales data with these data. So you're not going to predict what are my sales 1 year ago or 1 week back, right? You will try to mostly predict what are my sales next month or next week or next day. So there's no point taking the random samples here. So that's what Jeremy explains it.
Makes sense. Sean, did we answer your question? I mean, I could only come up with that particular example. It came up with the
Yeah, me too.
case where he was using
Whose dog is
used it.
it?
That is my dog.
Okay. Okay. Even if you don't have a Bing search, you can take photos of your dog and do a classifier on that.
Yeah.
Did we lose Sham?
No, I'm
Sean,
here. I'm here.
yeah.
Okay, okay. Did we answer you, Sham?
Yes.
Okay, okay. Okay, so moving on, the next thing we have here is the learner, which basically contains your data that we have generated through these image data loaders from the files that we have. And the next thing is your architecture, which is basically our model, which is a mathematical function that you're trying to optimize, right? So the learner is the thing that tries to figure out what are the parameters which cause this function, that is ResNet34 here, to match the labels in this data that we have. And the next thing is metrics. So the metric uh, so the metric we are using is the error rate. So what is a metric? Metric is a function that basically measures the quality of our model's predictions using the validation data set. And we have right. So the metric is one thing that we humans care about, because those are the predictions that we wanted, whether it is a dog or a cat. So we would basically focus on metrics. And we have also seen other thing in the last lecture, which is loss. So loss is nothing but the way the other Samuel has described in in his initial phase of machine learning, which tries to figure out how well our model is performing when we try to change the parameters a little up and down, right? So we are basically trying to change these parameters a little up and down, and to see which parameters are giving better results. So if you are trying to change the parameters a little up, and what are the results? So if it's giving those best results, we'll try to keep those parameters and will not change. So because it is basically working well for us with those parameters. So, and the loss is not same as metric, because when you change your parameters a little bit up or a little bit down, the accuracy or the error rate, which is our metric, will not change much. That is, our predictions, which are dogs, will not change to cats, right? Even if we change a little bit of parameters. But when it comes to loss, when you change the parameters even a little bit, there will be a change in the loss. So that's mainly the basic difference between the metric and the loss. But sometimes we can also use metric as the loss if it's a regression problem. So if you see in a linear regression problem, sometimes we basically use the loss. So take example of mean square error. So that can be used as a loss and a metric there. So there are some little changes, but and those are closely related. But loss is the thing that computer cares about, and metric is the thing that we care about.
So irrespective of what our metric is, the model would still be the same because we are not really modifying the loss function in this case,
Yes.
right?
Yeah. Okay. So
Like, have any of you tried a different metric? Like, for example, I actually tried to go through the documentation, but I couldn't find like what are the other metrics that we can use. Um, or this, for example, error rate is one of the metrics from what I
yeah.
believe there could be other metrics as well.
Yeah, I have used accuracy as well because it's basically 1 minus the error rate, right? So
Yeah, that's 1 minus error. I tried using AUC for one of the problems, but I couldn't get it to work. So I'm not really sure.
okay. So these are all the metrics that are available, Sham. If you want, I can post it.
Yep. No, thanks. Yeah, that's good. Thanks.
Yeah.
Docs first.
I have looked at only the error rate and accuracy because those are basically related to each other. And we are also, I think we also have precision, recall, ROC, AOC curves, and all. Yeah. Yeah, we can also use those. But accuracy and error rate are good metrics for classification, for some of the classification problems, I would say.
Yeah. Thanks.
Yeah. And the next thing I wanted to talk about was, yeah, and why and how to define those validation data sets. I think we already discussed about that, but why do we need a test data set too? So when you are setting aside validation data set, right, if you see, yeah, if you see here, we can change the parameters because we humans are training this model, right? So so based on the validation laws, we tend to change the parameters in our model, right? So we will try to change the parameters until we see a valid loss that satisfies us. So it's basically, maybe we are trying to overfit the model based on the validation data sets too. So that's why we would need a test data set also to basically see the model performance after validating our model based on the validation set. So that's basically why we would need a validation data set and a test data set too.
All right, makes sense.
Okay. So yeah. So the next thing we have looked at this is the learn dot fine tune. So learn dot fine tune is basically so why are we using fine tune? So we are basically using transfer learning, right? So transfer learning is transfer learning is kind of a technique used when you are using a pre-trained model for a task different from what it is originally trained for. So in this case, our pre-trained model is ResNet 34, and this ResNet 34 is basically trained on ImageNet dataset. But we are trying to use that pre-trained model and we are trying to predict whether it's a cat or a dog. So it's basically we are using a pre-trained model to a task which is different from what it was originally trained for, right? So what fine tuning does? So fine tuning is basically a transfer learning technique that updates the parameters for this pre-trained model, that is ResNet 34 in our case. by training for additional epochs, right? So we want to fit our model to predict whether it is a cat or a dog, not the labels that are in the ImageNet dataset, right? So that's why we are doing fine tuning here. So in Fast AI, by default, what happens when you do this learned fine tune? So what it does by default is it will use one epoch to fit the model, to fit those parts of the model that is necessary to predict what we want to do with that. So in this case, it would be predicting whether it is a cat or a dog. So we are basically changing the last layer of the pre-trained model to get, yeah, the last layer of the pre-trained model to get our own desired output. So that's why we would see a zero epoch whenever you do a learn dot fine tune. So this epoch is used to, yeah, change the parameters of the last layer of the pre-trained model. So after that, it will train for the number of epochs that you have specified here. So since you have given one here, it will train for an additional one epoch on all the layers of the model. So in the first, in here, it will freeze all the previous layers except the last layer, and it will train only that last layer. But when it is training for additional epochs, it will unfreeze all the layers, and then it will try to change the parameters accordingly to predict whether it is a cat or a dog. So that is basically what is happening when you are doing a learn dot fine tune.
So when you do fine tune, the first epoch is only for the last layer, and if you have further epochs, then it's gonna train on the rest of the layers as well.
Yes,
Is that
yes,
right?
yeah. Think
Have,
I have, yeah, that's what I saw, because in the source code I've seen somewhere that it has, when doing a fine tune, it has model dot freeze function there.
right.
Yeah. Um, don't have it here now, but I can share you those details later.
Okay.
But that is but what basically is happening. It will, for the first epoch, it will freeze all the layers except the last layer, and for the additional epochs, it will unfreeze all the layers and try to change the parameters accordingly. Okay, so that's it for the code. And Jeremy has also talked about p-value and dividend. So I will explain basically what it is. So he has taken a paper which is high temperature and high humidity reduce transmission, yeah, reduces the transmission of COVID-19. So in that paper, they basically claim that if the cities with higher temperature and higher humidity tends to have a lower transmission of the COVID-19. So, so to prove whether the claim is right or not, there's one mechanism in statistics which is hypothesis testing. So we use hypothesis testing to basically see whether that claim is right or wrong. So p-value is one way of doing, yeah. So yeah, p-value is one way of doing things in hypothesis testing. There is a traditional way too, but here they have used p-values to check whether the claim is right or wrong. So there are three steps in a hypothesis uh, testing. So the first one is to pick a null hypothesis. So in this case, we are taking that we don't have a relationship, but yeah. So the basic aim of the hypothesis testing when we are using a p-value is that if p-value is less than a significance level, then we will have to reject the null hypothesis. So the basic aim of the hypothesis testing is to test to reject the null hypothesis. So the claim in that in that paper is that high humidity and high temperature will reduce the transmission of COVID-19. So basically, our null hypothesis is basically the opposite of what the claim. So we will start with no relationship, and we will try to reject this null hypothesis so that what they are claiming is basically true or not. So the p-value basically will say what percentage of the time we would see that values. So, we would see the relationship between the R and the temperature, right? So basically, it is like a sometimes it may happen by chance, right? So since they are taking only 100 cities, so there's not much of a data. So sometimes it can happen by a random chance. So that's why we have a method to basically see whether that claim is right or wrong. So that's
Right.
where p-value is used.
And he ends up criticizing p-value and the method to
Yeah,
use
yeah.
p-value for deciding a lot, but I couldn't really get the whole point of it. I do understand one thing, that p-value is highly dependent on the number of data points that you use. So if you have a
Mm.
large number of data points, I mean, almost any minute difference would turn out to be significant. But other than
Yes,
that,
yeah.
he quoted, American Statistical Institute and some stuff
Yeah,
regarding
basically
bias and
he
distribution.
wants to say, I think, because most of the decisions that in the industry make are based on p-values. So he wants to bring this up because most of the, even in my day-to-day projects, we use p-values as a decision making factor. So he basically wants to tell you that p-values doesn't necessarily tell you whether your hypothesis is true or wrong based on the number of points that you have collected.
And
All
actually,
right.
I have
Yeah, go ahead, Shan.
I have been through a number of articles where say that even the researchers do modify the p-value to support their hypothesis. Like they, even researchers in papers, they do that. Maybe it's a small number, but people will have their biases, and they will find out data definitely which support their biases rather than the thing. However, I found that piece of COVID stuff very interesting because he started out as saying that this is a very small sample, and it uh, I don't find it that it is an accurate one and stuff like that. But then while towards the end, he said that this is a good data post set, and so uh, he I believe he showed the two ways you can approach any article or any research that anybody has done. First, you should be hesitant about accepting it, and then you should do your calculate, do have a go through it, do all your um, like first don't believe it, and then after do all your calculations, only then you should after you do all your testing, and then you find it satisfactory, only then you should believe that that was very um, good for me. Like it was a good way of analyzing the data that you see, analyzing the sheets or predictions that people make.
All right. Okay, is there any other criticism for using p-value other than the fact that it is highly skewed towards the number of data points?
I think p-value. So it's not only about the number of data points. It's also about the data that you collect. Like if you already have a bias and you go towards, for example, let's talk about the political system. If you're biased that one group is better than the other, then you may tend to go towards interview people or take response from people who are biased towards that as well, right? You may not be making an unbiased decision, and you may not be making an unbiased survey, and that will reflect in the data set, and that will reflect in the eventual p-value. I'm not saying the p-value is not a good statistic; it's a brilliant one, but I'm saying that it all matters about what the data is on which you are doing that p-value calculation.
Right. Okay, makes sense. So if you remove all the inherent biases that you might have,
And that's a pretty difficult thing to do. Yeah, I mean, like biases are what makes you
And there's also one thing we would
Haswant,
want
I
to
think there
consider.
is some disturbance coming from your end.
1 second.
Are you hearing it now?
Not anymore.
Is it fine now?
Yeah, I think it's Harshwant.
Yeah, it's my fan. Okay, so there's one more thing that we would have to consider when we are looking at p-values. That is the prior evidence. So Jeremy has talked about. I don't have a picture. If you look at the prior evidence and if your claim is supporting those prior beliefs that they already proved, then it is a good way to consider p-value. But if you don't have that particular evidence to claim when you are using when you are only using p-value, then you should not do it. If there is a prior evidence, then we may use p-value as one of the deciding factors. So that's what he basically tells in the end.
Yeah.
Okay.
So that's what I had prepared because I didn't have that being such API key. Question you want to show us small demo?
On the Bing search API?
Yeah, you can also show yours, Shyam. The JavaScript.
My
It's also interesting.
the JavaScript hack. Yeah,
Yeah,
I'll mail it to you. I will slide down. So it's not. So how many of you guys know JavaScript?
I know basics. That's all.
Okay. So it's basically when you hover over a mouse on what images for a 2 second. I have put a 2 second limited, and if I hover it for 2 seconds, it downloads. Otherwise, it gets very erratic. So I'll mail over the code to you. Yeah, I mean I will
Oh,
put it over a Slack maybe.
yeah, that's good.
Um, though I'm not sure whether they are legally allowed. Like a lot of pictures will have the EA stuff on it, right? That
Yeah,
trademark stuff, and so it's not definitely recommended for commercial stuff. But I think personal is fine. Nobody will fine us or sue us on downloading as
yeah.
long as we don't sell. We are not that rich to be sued.
Did you hover over 200 images and waited for 2 seconds on each one
So
of them to download this?
yes. So yeah. So otherwise, previously I had written a code wherein I just pick up some images from a new search, but that did not scale well. So classification was I had to manually classify everything and stuff. So I did one a different kind of where I just hold on for like a second, and then if I hover it for 1 second, then it will download the image.
Cool.
I'll probably share another code with you, the one from the previous course that Jeremy conducted. There they share a script that you can just put in somewhere in the inspect element part. and it downloads all the JPEG images on that screen. So if
Oh,
you just search for the word in Google, and then it's going on.
okay.
Nice. Okay.
Did you guys go through the entire lesson, entire chapter until the point that they host it on Binder?
Excuse me, can you repeat that part?
Did you guys go through the entire chapter or entire video until the point that he posts the the model on Binder?
No, I didn't. It's in the third
Oh,
lecture, right?
Yeah, because
I
you
did.
didn't have to
Oh,
bring it.
yeah. Are you asking he hosted the application on some website, right? I'm not sure where it was.
Yeah, he hosted it on Binder.
Yeah,
Binder.
It lets
using
you
Voila.
to put it on. Okay.
I
Okay,
skipped
so
that part
do we?
actually.
Okay, so do we have any questions related to any of that stuff? Otherwise, we can move on to the questionnaire. Any questions that we feel like discussing, and then we'll probably close the meeting for today.
So,
The next video
mhm,
has more content in it, so it would probably be more interesting.
yes.
There are more topics covered in the next one.
Yep. So Harshwant today showed the chapter 1 stuff, right? We are going through the chapter 1 basics and stuff, right? So do you want to discuss the chapter 1 questionnaire?
I think it's fine with me. Actually, we already did the chapter 1's question last time.
Oh, I'm sorry. I dropped off
Yeah, yeah,
last
yeah.
minute. Yeah, sorry. So do you
Yeah,
want
The
if
to
you
go
questionnaire
to
for
the
have,
chapter 1 is pretty.
chapter
yeah, if you
1,
have,
chapter 2 questionnaire?
yeah, sure. If you have any questions in the chapter 1, you can discuss those.
No. I really would like to know like the Jupyter stuff. I mean, I have to go through that, like the different commands available in Jupyter, so that it will be a much more better experience. Um,
Yeah,
but
the
yeah,
next section will be full of hands-on than theory. So that will be a good lecture to attend. Yeah. So who wants to volunteer?
so are we going through chapter 2 right now, or are we going to go over next section, next study group?
You're talking about the book
The
of
lesson
this?
as well. I think they both are similar, right?
No, no, no. The both are not. So lecture one
Okay.
covers half of the chapter one of the book,
Yeah.
and lecture two covers the second half of the chapter one and some of the bits in the chapter two. So it's the lectures are not aligned with the book. So
Okay. Okay. I actually went through the fast
And I
book.
think they're going to skip a couple of chapters in between from lecture.
yeah,
Yeah.
they skipped chapter three and went on to chapter four.
So
Chapter
so
So
three
how
is
are we?
we might,
basically on ethics.
So how shall we go ahead? Like, shall we focus on the book part, or shall we focus on the videos part? Because then it will be better
we
on
are,
a sync, right?
we are focusing on the videos, but the videos also cover parts of the chapters and the codes there. So we are referring to the chapters when we're doing the coding part, but for
Okay.
discussions we are limiting ourselves to the
Okay.
videos.
Okay. Okay.
So it will
We can
mostly
discuss the
be
questionnaire from chapter 2 if you guys are interested, because I mean the second video basically covers most of chapter 2 except for the part where they're hosting it on Binder, so we can maybe skip those questions and then address the rest of them if any of them find is
Yep.
confusing to us. Yeah.
yeah, sure.
Yep.
Yeah.
So
So who wants to lead the next session? I would have done, but a bit busy.
can you guys see my screen?
Yeah,
Yes, I
yeah.
can.
Right. So these are the questions. Let's just go through them quickly, or maybe just read the questions, and if you do not already know the answer to any one, just let us know and we'll discuss.
Feedback loop. It's a command that displays a tensor, and so here is L3.
I think for answering a lot of these questions, we need to have gone through the chapter 2, right?
Yeah.
Yes. Most of it is that parts of, and we have not done that yet.
I have been following the book rather than the videos. I mean, I have a look at the videos, but I'm going through the book, but because that gives me a deadline, and it's like you have to complete this before this meeting and stuff. So I have gone through it.
Okay.
I'm not sure like anyone else
Haswant
has.
hasn't. Maybe we can discuss it next time once you go through the chapter and just go over the question and mark any question that you do not understand or you would like to discuss, and then we can discuss it next class first thing, and then we can go over the video discussion.
Yeah.
Makes
And
sense.
actually, the next chapter is a lot about data ethics. Now that's a very interesting point, but I just would like to know, like, are we going to discuss data ethics in this group?
No, I
I'm not
think
against it. Yeah. Yeah, that's what I
the
wanted
next
to.
video
Discusses
theory. No, I think they're going to skip to chapter 5 in the next video.
Okay.
Probably
There's a lot of material to cover then.
Yeah, this course will be of 2 or 3 parts. So the book will be covered in like 2 or 3 courses. So,
we are not yet certain if they're going to release a couple of more, courses to cover the book, but he does mention that if we were to cover the entire book, it would take a couple of 2 or 3 courses.
Yeah.
Oh, okay.
And Sham, if you are going through the book, then you would have to skip the 3rd chapter because the videos for now doesn't cover that chapter.
Okay. Yeah, I mean, I will go through it, but like we can skip that discussion. It's a very interesting read from a psychological and like the usage point of view. So it's a bit philosophical in nature. So it's quite a bit of interesting read, the different human natures discussion and stuff. It's a
There's
good read.
also a course on data ethics. They have a ethics course that Rachel teaches. So if you go to ethics.fast.ai, you will see
Oh,
that
is
course.
it?
Yeah. So it's basically
it's essential to keep in mind the usage of the model that you build, and how if it's usable or not. I mean, just building a model doesn't really serve the purpose as long as it cannot be used or doesn't serve the purpose.
Earlier they used to have 2 courses for data ethics and the book. So in this course they wanted to include
Both of
not
those.
in the course, the book they wanted to also include data ethics too, so that's why they have included in the chapter 3.
So did you guys go over course 1 questionnaires, right? You have gone over the course 1 question in the last section, last study group?
Yes, we already did that.
Okay.
So the questions are pretty straightforward.
Mm-hmm.
If you have any confusion regarding those questions, we can still discuss them if you like.
No, I just wanted to know, like, there were different kind of architectures that were used, right? One was ResNet, and I have a couple of others as well.
There
So,
is
yeah, and like the usage that they have done, right? The virus part and stuff, which was pretty cool. So, yeah, that was really awesome. Just wanted to talk about that.
Which one?
So in the course one, right, a couple of, so Jeremy mentioned about the deep learning, not just used for image classification. It has been used, for example, for making gunshots, the example of gunshots that was given,
Hmm.
and the pattern recognition, right?
Right,
Fraud detection
right,
that was done, and the virus part,
right. That
which
was
was
cool.
pretty surprising. I just wanted to give a shout out to those stuff. Like I never like, I mean, that kind of creative thinking.
Right. That's I guess the benefit of creating this abstract on top of Keras, on top of PyTorch, that lets the industry people use, not so data science people use uh, good quality in deep learning and then implementing it in their daily work. That lets
Yeah,
us, come up with these creative applications of deep learning.
that was just wow. Like I could have never thought of doing that virus samples
I like
to
the fraud detection thing too. I mean,
yeah,
that's
Yeah.
fraud
pretty cool.
pattern recognition, I
Yeah.
believe. That's there.
Yeah. And also converting time series into an image and then using that as for image classification. Detection.
Good examples.
Right. Also on the forum, the Fast.ai forum, there is this particular topic that says share your work. A lot of
Hmm.
people have shared, the all the different projects that they've worked on over the last 3-4 years since the course's inception. So they are pretty cool posts over there.
Oh,
I'll
that's
probably put the
nice.
link. Hmm, I think maybe
I
it's
think
somewhere else.
that would be hugely beneficial to expand our horizons, like where all can be used. Like till
Yeah.
actually till that virus part, I never knew that image classification could be used to do that. Like I never thought of that, and now it has just expanded all the possibilities. Before we, I think before we are planning to break for the day, right? Or uh, is there any
Yeah, yeah,
discussion?
yeah. I think we're
So
done.
asking like are any of you doing any personal projects while going through it, or you're planning to do once the course finishes? Once you have a good understanding, any personal project that would like to? I think that would give all of us a goal of using it as soon as we complete this course, right? So has any of you thought about what you would use it for?
Mm, I wanted to do a simple project for now, like image classification problem or image segmentation problem. So there's this one Kaggle dataset that I found.
So, I,
This is basically on fashion to segment each part of the dress. So I found it that interesting, so wanted to work on that after this course.
Cool, cool, Ashwant, cool. That's good.
I was planning to participate in a couple of Kaggle competitions, but yeah, that's still a long shot.
Yeah,
Complete this course.
maybe we can team up. I'm just saying.
Yeah, we could do that. Yeah,
Yeah, we can.
that would be
I
fun.
person I personally like was trying to replicate the Google Photos of classifying the picture of your like mine, me, like my friends, or like my family members into different folders, kind of stuff. I'll personally would
Yeah,
like to do that.
yeah. I was
That
thinking about it just before we started the meeting. I mean, so a few days back we were looking for my grandfather's pictures, but I have so many pictures on my hard disk, but I couldn't really
yeah.
figure out
I
where
mean,
his pictures were. So I was thinking maybe.
and everything in like you otherwise you have to do a lot of labeling, so maybe I'll do a few of my labeling and then let the image classifier
Yeah,
sort out
exactly.
whoever it
Yeah,
is. So that is what I was thinking, a
right.
pet project of mine. And actually one
Mhm.
another thing that I was as I was going through chapter 2 that we had done was data augmentation that we're that Jeremy
Right.
is talking about. So I think that maybe I'll use somewhere to the old photos that we have, maybe shape it fine, maybe brighten it, maybe color it. I think that would be really cool to do. So that is something that I'm getting out of this project, if not anything else.
Yeah, using deep learning, you can also improve the clarity of your old pictures. That's
Yeah,
one use case I have seen something. So that's also pretty good to do.
yeah, that's what I'll try to do. Let's see how successful I am in about 4 months' time.
Sure. Share the results with us, Shyam.
Yep.
So this is the newest forum topic that you can refer to for projects that people are working on.
I think earlier one they used to post it on Medium, right?
Sorry?
The earlier parts of the course they used to share their work on Medium. It's a publication for Fast.ai, I guess. I think they used to share their projects there.
There was a topic over here, but I cannot find it at the moment. I'll post it in our channel once I find it.
Yep. Hey,
Sure.
yeah, there's a
Right.
share your V2 projects here. Is that one you're talking about? Share your
Yeah.
V2 projects. I saw something like that.
This is the latest one. There's a previous version of the same post where there were a lot of interesting projects.
Okay, cool.
Yeah. All right. So I guess that's it for now. Next
Yep.
week, you're going to discuss questionnaires from chapter 2 and then the next week's video.
Yep.
Have shared in the chat the previous ones. Projects. Previous.
And Osha, like the Google Images search query, right? That
Yeah.
would be great. I don't have
Yeah.
to wait for 400 seconds or something like that.
Yeah. I'll do that.
Yeah.
I'll share it right away. Yeah.
Yep.
Okay.